All right, so what we're here to talk about today is a little bit about ecology, and really we're here to talk about water resources. And really, it's about water resources for a sustainable future. Leonardo da Vinci once famously said that water is the driving force of all nature. And I think that most of us that are here tonight are probably here because we care about the future of water, or we have some stake in the Kansas water future somehow plays into a role in our lives. So what we're going to look at tonight are we're going to look at just a few of the basic water regulations. Some of the more important ones we could probably spend more than a few hours here just talking about water regulations in general. But we'll just hit on a few of the more important ones that will kind of play into it, and some of them will be threaded throughout the conversation this evening. We will look at public water supplies, we will look at utilities, we will look at how they're used, and we will look at where that water comes from. We'll also talk about the Kansas Water Office, the Kansas Water Authority, and those regional advisory committees that have been established for the last couple of years. Then we'll move into looking at the groundwater resources that we have in western and south central Kansas, as well as wrapping up with some of the current and emerging issues that we see in water in Kansas today. Then we will have a little bit of time left at the end for some conclusions and a wrap up with some of your questions. So let's kind of move into what some of the environmental regulations that are around today. The first one that really comes to mind are the Kansas Surface Water Quality Standards. These are the ones that are going to deal more directly with those of us here in eastern Kansas that turn on our faucet and get drinking water. They have to do with some of the water that we use recreationally, as far as aquatic life, as far as our public health. They also have to do with, when we get out a little bit west, they have to do with the agriculture and the water that we use there. Some of the things they take into account are temperature, dissolved oxygen, pH. Those are all indicators of the quality of water that we have. We also have another policy that was implemented called the anti-degradation policy. The anti-degradation policy was a policy that was put into place that limits kind of the discharges and other activities that negatively impact the quality of water. Not all water that's taken out of the ground or off of the surface water is actually used. Some of it is just put through a process, but there's some amount of degradation that takes place. For example, a water treatment, or for example, a coal-fired power plant that pulls the water out and uses it to create steam, or uses that water for cooling, discharges that same water back into the same watershed that it came out of. However, that water has been degraded a little bit, either thermally or chemically, or something that may have happened to it. With our public water supplies that are here in Kansas, there are over 1,000 public water supply systems in Kansas. This includes municipalities, water districts, and privately owned systems. The public water system regulations that are operated by the state of Kansas are regulated by the Kansas Department of Health and Environment. They establish the regulations that apply to it. They establish the fees that are associated with water quality. They also establish water monitoring and reporting procedures. They have developed a priorities list of where there may be issues, and they have access to loans and funding for different local programs. So some of the regulations that go along with public water supplies, there's coliform, nitrates, inorganics, organic constituents. We have lead and copper rules, radionuclides dealing with the alpha beta particles. We have disinfection byproducts. Then we have surface water treatment rules that have to deal with sanitation. We have groundwater rules, and we have consumer confidence reports, as well as public notice rules. So those are just a few of the different things that have to do with some of the regulations. And this is where we kind of get into, we could be here for several hours talking about all these different rules individually. we will kind of hit some of them as they thread through some of our discussions. So let's talk about those public water supplies. We mentioned that there were, over 1,000 public water supplies in Kansas, roughly. Here's where they come from. Now, what's interesting is you notice that 53% of those public water supplies supply water for between 0 and 500 people. So we have a lot of small public water supply systems in the state of Kansas. And the interesting thing about that is the number of times that you have to monitor a public water supply is based off of the number of people that draw water out of that supply system. So if you are 0 to 500 in the public water supply sector, you only have to monitor twice per reporting period. So as you go up in number, then we have about 14% are between 500 and 1,000. The next largest group we have is between 1,000 and 3,000, which have about 22%. Then 3,000 to 100,000 has 94. And then we have over 100,000, there are only 5 public water supply districts. Those are the ones that have to monitor the most. And they have to monitor upwards of 30 times. So they are monitoring at least daily the water that is being discharged or being sent through and treated. So the community systems by water source. So where do these sources get their water? We notice that the majority of them get their water from groundwater. When we look at these two, we look here both at groundwater and groundwater purchases. We have over 500 that are both groundwater and groundwater purchases. Then when we look at surface water and surface water purchases, and the difference between a water and a water purchase means it still comes from the surface or the ground, it's just pulled out by one company and maybe utilized by a different. So in this case, one company pulls it out and maybe sells it to another company. So Water One can pull it out and sell it to another municipality. Or Olathe can pull it out and sell to a smaller community around it, is just an example. So whenever we look at those, we look at what comes from surface waters. We see that about 40% come from the surface water and about 59% come from groundwater. So, we have there's about half and half, about a 60-40 split there where we get those. So we get about 60% come from groundwater derivatives, 40% come from surface water. The groundwater primarily comes from the south central and western Kansas, and here in the north, in the eastern and northeastern sectors, we get primarily surface water as our source water. So what do we use that water for? Well, whenever we're looking at regional water uses, we can see that this is statewide. This is why we have varying differences in the state of Kansas. When you're here in the eastern portion of the state, you can see that municipalities take up the majority of the usage of that water. And as you go west, there's a much heavier irrigation use of that water. Now, we have some differences in here. You notice also that we have industrial uses here in the eastern United States. A lot of the industrial use is actually pulled out by power plants, and that's water that is pulled out by the power plant and utilized. So it's not necessarily used. Again, it's some of that water that's pulled out and put back and discharged back in, but it still could be degraded. It still goes through a process. So whenever we look at just in here regionally, we're going to look at this specific Kansas region here as we look at this region, because that's the region that we find ourselves located in. When we look at what it gets used for here, and just looking at some of the different counties that are available to us, when we look at Johnson County alone, the majority of Johnson County is used for municipal water sources. Now we have, when you get into southern Johnson County and out into western Johnson County, we do have some used for irrigation. But when we move over to Douglas County, we see that we have municipal and we have industrial, and that industrial usage, again, is pulled out by the power plant. Whenever you go north a little bit to Leavenworth County, we have mostly municipal, a little bit pulled out for industrial use. And again, we have a small agricultural section that pulls out for irrigation. Now, the other numbers that we look here as to where this water comes from, 66% of it in Johnson County comes from groundwater. Whenever we get up into Leavenworth, 87% of the water that is consumed in Leavenworth is groundwater. But when we look over in Douglas County, we see that only about 16% of the water that is utilized is groundwater. And that's just some different issues. It just has to do with where the water systems pull their water out of. Do they pull it out of surface waters like the Kansas River, the Missouri River, or do they actually pull it out of groundwater sources? So let's look at kind of how the water vision has to be developed in Kansas. And in October 2013, Governor Brownback called for an action, and he said that what we really need is a vision for the water future in Kansas. And he stated that we needed a 50-year vision. And he stated that water and the Kansas economy were directly linked. That water is a finite resource. Without further planning and action, will no longer be able to meet our state's current needs, let alone growth. And he is exactly right when he says this. So what Governor Brownback wanted to do was incorporate the vision action items into a water plan that would formalize a process and kind of organize everything. And he came up with this vision to organize everything regionally. And the Kansas Water Office came up with regional advisory committees. And there were 14 regional advisory committees that were set up to provide a framework, policy, and tools to kind of balance conservation and economic growth. And these plans were set in place starting about August of 2015, so a little over 2 years ago. And they were kind of given 1 year to get their feet under them. And then they were to each develop their own action plan and send it through the Kansas Water Authority. Now, the Kansas Water Authority is a little bit different. The Kansas Water Authority is an advisement group that is set up by the governor and by the legislature that kind of advises the governor on some of these issues. And they are the people who were tasked with kind of picking these regional advisory committee members and identifying those stakeholders that would be able to best help advise the state officials on what was going on in each region. So they broke out the 14 regional planning areas like this. The ones that we will kind of look at primarily are the ones over here that were in our region in the Kansas Regional Advisory Committee, which happens to be the largest regional advisory committee in land area. We also have the Missouri Regional Advisory Committee, which is up in northeastern Kansas. And then we have the Mary DeSeen, which falls kind of parts of southern Johnson County, parts of southern Douglas County, going down along south or east central Kansas. So what each of these regional advisory committees were tasked with doing was coming up with what their focus areas should be and what the issues would be in their area. The Kansas Water Office then asked them to get back with them and tell them what the biggest issues were. What they identified was education was actually listed in almost every regional advisory committee as a critical issue. And education just on water issues, water regulations, and water resources. Also, money and finance and spending were a big issue for most of the regions as well. The regional advisory committees and the constituents wanted to develop plans, they wanted to raise money, and they wanted to be able to spend that money locally. Therefore, they wouldn't have to worry about a lot of the other bureaucracy that takes place. So, how does all of this get funded? Well, this is one of kind of the bigger issues. We have kind of a broad picture of how it gets funded, but I think there's a lot of things that probably aren't understood still. As we look currently, the estimates that the Kansas Water Plan is funded to about $8.7 million. Of that, $904,576 comes from the general fund. The rest of it is made up in water taxes that are collected on municipalities and a few other programs that are out there. 2018, which is recommended in the budget, that number stays pretty much the same. Around 8.7 million, 902,000 comes from the general fund. Now, where these numbers are a little shaky and have been changed is if we go back to 2011. This is when the Kansas State Legislature suspended a $6 million demand transfer to the State Water Fund. And that demand transfer was supposed to be matching funds that the state was supposed to put in, matching some of the funds that were collected through municipalities. Well, the state legislature suspended that transfer, and on top of that, they transferred money from the state water plan to other plans within the state that they were supposed to fund. They took $75,000 and put it into the Grain Warehouse Inspection Fund, $175,000 and put it into the Swine Eradication Fund, and $20,000 to put in the Marketing Reporting Fund, which have never been replaced. And when people ask questions about these, they don't get a lot of direct answers as to when this money might be replaced or as to when the funding might come back into the picture. So Kansas didn't have a real answer for this. So they came up with some other funding ideas. They tried to get a little bit creative and make some suggestions on how to raise funding for water issues. And this was a blue ribbon task force. One of the things that they came up with was just a straight across the board sales tax. And with a sales tax, it was interesting because they thought that they might be able to come up with around $40 million in just a sales tax alone on water. Then they thought maybe another issue they could come up with was a bottled water fee. Now, the thing about the bottled water fee was they weren't necessarily going to charge the consumer the bottled water fee. They were going to implement it at the wholesale level. But what happened was they kind of estimated that if they put that fee in at the wholesale level, it would just be passed down to the consumer. Another thought was to come up with irrigation fees, because as we currently have, the state water office does not collect any money on that groundwater or irrigation fees that take place for any of those uses. It was kind of decided by the task force that there wasn't much of an appetite for fees or taxes to be put into place at that time. So therefore, they decided to kind of table some of those issues. There was a potential there to generate about $40 million or more just in taxes or fees or something like that, but they didn't feel like there was probably much of an appetite in Kansas for that at the time. So let's get back to some of those focus areas that the regional advisory committees had. The Kansas RAC, which is the one that we are primarily located in here, identified two major source areas. And the first one is sedimentation. And that's sedimentation of the reservoirs primarily and some of those surface water holding areas. The second are algal blooms. The Missouri Regional Advisory Committee, which is up along the Missouri River in the northeastern part of the state, identified groundwater safety and surface water. The primary water use is for municipal use in this area, so that's primarily what they were looking at. The Mary-Decine, which is east central Kansas, identified sedimentation and education as their two top priorities. So let's look at the Kansas critical focus areas. So first we have sedimentation. And they said that Kansas faced a reduced surface water storage, specifically in eastern Kansas, which is caused by sedimentation of its reservoirs. And not only did they look at this in the regional area, but they looked at this statewide when we look at this as well. And there are 24 federal reservoirs in Kansas. The average age of the reservoirs in Kansas is about 50 years old. Current estimates indicate that there are about 17% of the collective storage capacities of these have been lost by sedimentation. So we've lost 17% of the storage capacity of our reservoirs. 6 of the reservoirs are considered to be critically infilled at 33% or more, meaning they've lost over a third of their storage capacity. And let's look at some of those reservoirs and where they might be located. Some of the things that we have to look at for sedimentation is, what does it do? Sedimentation affects the useful life of the reservoir, but it also impacts its ability to be used for flood control, and it impacts its usefulness as a water source due to some of the minerals and metals and things that can be stored in the sediment. But we look at some of these here, and we look at a lot of the sedimentation does have to do with the age of the reservoir. We look at some of the older reservoirs that are out there, and those are the ones that tend to have more sedimentation. Whenever we look at some of these, Turtle Creek Lake down here is 33% loss of capacity. We see Cedar Lake has a 50%, Mission Lake 50% loss of capacity. Crystal Lake, over 100 years old, has a 55% decrease in storage capacity. And this has all been by sedimentation. And some of the other consequences of sedimentation are the loss of storage, the buildup of contaminants. And a lot of the contaminants that we're looking at building up are, again, some of those minerals, some of those metals, and some of those other byproducts that we have of past chemical usages. So what causes this sedimentation? Well, the major cause of sedimentation is actually just erosion of the stream banks. So some of the solutions that were come up with were that we could start monitoring and figuring out how quickly they were sedimenting in. We could educate and get people to understand better how they could implement some best management practices or better management practices along these stream banks. And then the state of Kansas could start some stream bank stabilization projects. This stream bank stabilization project became one of the focus areas for a lot of the regional advisory committees. It was a coordinated effort, and is an ongoing coordinated effort, between the Kansas Department of Health and Environment, the Department of Agriculture, and the Kansas Water Office. They identified some to start off with: the Big Blue and the Little Blue, which fed into Turtle Creek, the Delaware River, which feeds into Perry Lake, and the Cottonwood and Neosho Rivers, which fed into the John Redmond Reservoir. So those were some of the first ones in the stream banks that were stabilized, helping those reservoirs. There were also 18 new projects that are expected in the future to prevent over 1 million tons of sediment from entering the reservoirs in the state of Kansas. So these will be ongoing and continual as we go into the future. Part of this Kansas Water Office plans, and they are prioritized by year going through these. So there are some good projects going on here, as well as establishing other regulations that have to do with setback distances and things like that going forward. The other topic that was notified within the region were algal blooms. And the algal blooms kind of are these marine and freshwater harmful algal blooms. And they can occur in the water in water anytime, and they impair the use of that water because you get excessive accumulations of algae. And in freshwater, a lot of times what happens is the algae builds up, and that algae then releases toxins. And it's a lot of times caused by cyanobacteria. And that cyanobacteria causes a lot of water quality concerns, everything from it being aesthetically unpleasing, having odors to it, it's malodorous, to developing potential human toxins to animals and humans, and some of those problems that would exist out there. So a lot of times it is kind of aesthetic, it's taste and odor compounds, but the toxins are of a particular concern in the lakes and rivers that can enter drinking water supplies or have problems if we use those lakes or freshwaters recreationally. So those algal blooms, here's some of what they can look like. And again, aesthetically, they're not very pleasing, but they produce these chemically, bioactively diverse group of toxins that can cause skin irritations and things like that whenever you encounter them. The Cheney Reservoir in south central Kansas has kind of had some historical past issues with algal blooms. The state issues advisories for these. A watch means the conditions do exist for that, and water contact is discouraged, and they will have signage up, and you can always check the Kansas Department of Health and Environment website. If it's a warning, there will be unsafe signs posted and water contact should not occur. And currently there are only 3 watches going in the state, but we've kind of entered the time of year, one where people aren't doing a lot in the water, and we don't have many issues of algal blooms throughout here. Usually the height of those run from Memorial Day to shortly after Labor Day. So let's take a look then at some of the groundwater issues that we have in Kansas. And the groundwater is identified as any water that can be pumped from a well. So any well that is dug, regardless of how deep it is, it does not indicate depth here. Groundwater does account of 0.6% of Earth's total water, and it's over 80% of the water that's used in Kansas actually comes from groundwater. Nearly 90% of that water is drawn somehow from the Ogallala or High Plains Aquifer. And we'll look at the different sections of the aquifer here in a little while. This use at 90% of it is not sustainable, as it is considered non-renewable. That means we're using water out of the aquifer faster than it can replenish. So in 1945, Kansas was actually pretty forward-thinking, and they passed the Kansas Water Appropriation Act. And that kind of set forth standards as to how they would regulate the use of groundwater. And currently, most Kansans do not take out the amount of water that they are actually permitted to. So I guess that's a positive that we can look at, as we currently aren't taking out as much as we could be. And in 1972, the Kansas Groundwater Management District Act established 5 separate groundwater management districts, and they kind of gave them a little bit of autonomy to do with and manage new wells and issues that they have within their region, and kind of handle those on their own. Agriculturally is primarily what we're looking at here. So let's take a look at that High Plains Aquifer. Well, the High Plains Aquifer, it underlies about 174,000 square miles of the central United States. It's east of the Rocky Mountains, and it's really the southern part of the Great Plains. Included are 8 different states, starting in South Dakota, Wyoming, coming down through Nebraska, Colorado, then Kansas, Oklahoma, New Mexico, and Texas. The High Plains Aquifer is the shallowest and most abundant source of water in this region. Without access to this, really this region would be a desert area. So let's look at the Kansas components of this aquifer. A lot of it gets referred to just as the Ogallala Aquifer because that's what we understand it as. But there are kind of different components or different sections of this. The Ogallala Aquifer is part of that, the Great Bend Prairie Aquifer section, and the Equus beds that we have that kind of move over into south central Kansas. So let's kind of look at groundwater and how much there is. And the only way to really establish this is through the groundwater modeling. And a groundwater model is a tool used to represent the approximate natural groundwater system. So approximately where it is, they can measure its depth, and therefore they can also measure its capacity through using mathematical equations to simulate water levels and identify different stream flows in the area. So these different areas that we see here are a lot associated with the groundwater management districts that we have and set up in those 5 management districts. But they're kind of broken up here by aquifers and their models. So we have the Ozark, we have the Northeast Aquifer, the Northwest Aquifer, we have the Solomon North Folk Aquifer, we have the Solomon South Folk, we have the Groundwater Management District 3 model, and the 3 and 5, and then the 5 model. So some of them interchange each other down in there. The Equus beds model in the Ozark model. So a lot of these have provided us with a lot of different information in these models. The estimated lifetime of the High Plains Aquifer is probably one of the questions that a lot of people have. How long will this water last? Well, unfortunately, when we look out here, the brown areas means that they've already reached their minimum threshold, which means that they have already almost used up their usefulness. Now, when we look at the areas that are in red, we're looking at those areas have less than 25 years left. Then those areas that are in kind of an orange have, and it's hard to distinguish the colors, but have between 25 and 100 years of their useful life left. And this is at continued consumption rates of what we currently have. Some of the areas are getting into the center where we get into some of the deeper parts of the aquifer, and they have 100 to 250 years left. But what we really want to look at is how fast we're using it and the level changes recently. And as we look at some of these, we can see everything that's not in blue essentially has had a decrease over the past 5 to 7 years, has decreased in its level that's there. And a lot of times in some places in this aquifer, we are seeing it drawdowns of 6 feet annually. So we are seeing some very, very significant drops in places in the aquifers. So that means, and in places it's estimated that they're taking out 6 feet, and at most it recharges about 1 inch per year annually. So a lot of people are kind of suffering some of these consequences agriculturally of drawdowns on the aquifers. So what are we using this groundwater for? Well, it's estimated that Kansans use about 5 billion gallons of groundwater per day. And the average Kansan, however, only uses 160 gallons of water a day for private use. So in your home, municipally, you're only using about 160 gallons of water a day. But when we then tack on all the agricultural use of that too, when you factor out that as a population, that means that Kansans, on average, are using 2,800 gallons of water a day. Now, I know that number may seem a little weird and is a little bit skewed, but when you really think about it, in this state, we are the ones who are bearing the burden of the water usage, even though Kansans are producing and growing products for other states. What we have to look at is we are bearing that burden. It's our water, it's our problems, and so we have to look at this number, in my opinion, that we are using 2,800 gallons per day. My question then, is it sustainable? I think it's an easy answer from me that no, that is not sustainable for the future of Kansans. So what are we using this groundwater for? Well, obviously the biggest portion of it, 94% of the groundwater that's used in Kansas is used for irrigation. Then the next biggest use is municipal water supplies, and that's probably about what you would expect based off of what we just talked about with our usage numbers and what we've looked at, 160 versus 2,800. So those numbers are right in there. Then rural domestic use, livestock use, and industry use all come into play as well for groundwater. But what we really have to look at those numbers are irrigation use. That's where the most of the water is being used. So what are some of the issues that we have with groundwater? Well, and it's not a lot of different from what we see with surface water issues. We have the stream aquifer interactions, and this is something that we just really need to gain a better understanding of, are the interactions of the discharge that we have from the surface water into the groundwater and those interactions. Where does the recharge take place? How does it take place? How frequently does it take place within these watersheds and stream systems? So this needs to be studied over a much longer period of time. We need to be able to determine how the flow rates, how floods, how droughts can all affect these interactions. And these would be extensive studies that would need to be done here locally in the state of Kansas. Then we have to look at water quality, and there's a lot of information to go here, But some of that water quality that we have is natural water quality intrusions. Mineral intrusions are the main threat that we look at here. And really what it comes down to are the salt beds that are located in the shallower areas of parts of the aquifers near the surface. Usually this is around central Kansas. And what can happen is the fresh water will flow and pick up some of those surface salt waters and brine containing situations, and they can push them down into the aquifers. So we really need to get a more detailed understanding of the hydrology, geology, and kind of those interactions in those aquifers to understand this better. And right now I don't know that we have an understanding of how much leaching does take place into some of the groundwaters around there naturally. It's a challenging research problem, but the issues are very important to kind of understand this. And especially as we have some of the drawdowns in some of these aquifers, we may have some of that salt and that brine solutions that get pulled down into the deeper aquifers out of the shallower areas as well. Another one is the artificial contaminations that we have. This is kind of the human contaminations that we have with it. And some of these things are the so-called point source groundwater contaminations, landfills, industrial discharge, underground storage tanks, and injection wells, just to name a few. These are getting better, but we need some of these better management practices to be in place and to be followed heavier, and maybe even have some regulations behind them. But again, what we really do need is a better understanding of when and where the surface and the groundwater interact. So again, kind of tying everything together, we talked about these issues separately with surface water and with groundwater, but really they are very much tied together in the big picture of water issues. So the next thing we're going to kind of look at is groundwater sustainability. So let's look at some of these numbers. Since 1997, groundwater levels have shown declines in all of the wells that have been measured on average. So for the last 20 years, we've been showing declines in groundwater levels throughout Kansas in some 1,400 plus wells that have been monitored. The drought that was previous to 2015 started showing steeper declines. Between 2009 and 2015, the declines were much steeper. Since between 2015 and 2017, we've seen declines, but we haven't seen them declining as much. So what does all of this mean? Well, it really means if the current trend continues, the High Plains Aquifer could be depleted within 50 years. And this, I think, is probably where Governor Brownback kind of came up with this 50-year vision for us. So let's continue to look at some of those future projections that have been put out there. By the year 2060, which we're looking at 43 years from now, if we continue to use water out of the aquifers at the current rate, an additional 39% of the aquifer's reserve will be used. Now, when we kind of go back and look at that historically, prior to 1960, only 3% of that aquifer was used. By 2010, the next 50 years, we'd used 30% of the aquifer. So this kind of indicates that we are using more water out of it and we're using it faster. So it is estimated that water use in Kansas will peak around the year 2025. So one note that's kind of on the positive side is that crops have seen a 2% increase in production per unit of water. So that's a hopeful sign. We're using more water, we're growing more crops with less amounts of water. So fewer gallons of water per bushel of corn or per pound of beef is being used. So we have been able to increase productivity while decreasing the amount of water that is taken. So the bottom line is that every bit of water that we can save today could be paid back twofold, because as future technology comes on, as better crops come out there, better genetic diversity comes with crops, maybe they can grow with less and less water. And as that happens, as they can grow with less water, we can save some of that water to grow those crops in the future and become more sustainable. So the next thing that we're going to look at are some of those current and emerging issues that kind of take place or are taking place currently. Now, again, this is something that I've kind of picked some of the ones that stick out to me. And the first one being the fracking issue. Between 2000 and 2015, the number of fracking wells in the U.S. went from 20,000 to 300,000. And in Kansas, the USGS, or Kansas Geological Survey, approximates that we have 244,000 oil and gas wells in Kansas. And the total number, and of those wells, 57,000 of them are fracking wells. So almost 1/4 of the wells that we have in Kansas have been hydrologically fracked. Now, where are those wells located? Well, here's a map showing where those wells are located. And you can see most of them are concentrated in south central Kansas. The permitted wells are in blue. The wells that have already been drilled are in red. And then wells that were permitted after 2014 are circled. Now, we do have a couple over here that are of our concern, southern Johnson County, one down here in the corner of Franklin Douglas County. And what is being done with those is of concern, because a lot of us have concern about what some of the chemicals are that are used in this process and what happens with some of that wastewater. So let's kind of look at who's responsible for that. And what's interesting is the Kansas Corporate Commission is responsible for regulating fracking in Kansas. The commission enforces regulations on the following issues: monitoring potential seismic effects on the fluid injection, well construction, casing, and cementing of the wells, the protection of underground and surface water, the reporting and disclosure of types of fluids used in fracking, of what volume and description of each chemical additive used in fracking, the maximum amount of surface and injection pressure used during the process, spill prevention and cleanup, and any other information that is necessary for the regulation and fracking and safety of the environmental protection. So let's dig a little deeper into this. As of March 2017, the Kansas regulations require fracking operators to complete and submit a list of chemicals that are used during the fracking process. That sounds great. However, operators that consider a chemical or concentration of chemical to be a trade secret are allowed to withhold these chemicals from public disclosure and thus disclosure to potential competitors. And I think that's probably one of the bigger problems that the public now has with this fracking process, is there's not the transparency that we would like to see with it. Now, let's look at some fracking issues in general. A Duke University study, they studied 9 years from 2005 to 2014, and they said that there were about 250 billion gallons of water used in the fracking process. They found that this produced about 210 billion gallons of wastewater. So that their numbers break out to be that there was about a half a barrel of wastewater produced for every barrel of oil. And that led them to the question of, is it really worth it? Is oil a more important commodity than water? And the researchers that did the study there, actually said no, that the water being wasted or lost was more important than the oil that was being generated. The EPA has released a statement that says that there is scientific evidence that hydrologic fracking activities can impact drinking water resources in the United States under some circumstances. But it took them a long time to say this, and they don't honestly really back it up with much other than that statement. So another current and emerging issue that we have in Kansas is the city of Pretty Prairie. It's a small town of about 650 residents west of Wichita and south of Hutchinson. The city of Pretty Prairie has exceeded the state and federal maximum contamination limit, or MCL, allowed for nitrates in drinking water. Not only have they exceeded it, but they have over doubled the amount of nitrates in these drinking water, and this has been an ongoing problem for over 20 years. The city now says that they will provide bottled water for citizens who are pregnant or have children under 6 months of age. and they have continued to do so. And the most recent samples that were collected on November 6th showed that they had 23.6 milligrams per liter of nitrates found in the water. They have drawn water from the Equus Beds Aquifer. It's a shallow well that they have. It's about a 30-foot well that they draw water out of for the city. They have proposed a new reverse osmosis water treatment plant, but they did not, and the water treatment plant would have cost them about $2.2 million. They applied for a $500,000 federal EPA grant to make up some of the funds on that, and they were denied that. So they have to continue just offering bottled water for drinking water, and they really don't have any other recourse at this point. So they have said they will reapply for the grant again next year. Another current and emerging issue that's kind of a little closer to home for some of us here is in Lawrence. The state has authorized the city of Lawrence to release millions of gallons of nitrogen-contaminated water from the former farmland fertilizer plant into the Kansas River. They have stated that they can release about 30 million gallons of contaminated water between now and April 1st. This is a former farmland chemical fertilizer plant site. The city now owns the site and has so far received over $8 million from the trust fund for its remediation. And the Kansas Department of Health and Environment has stated that they've conditioned this discharge so that the river really assimilates the nitrogen load quickly and disperses it. And we don't anticipate any significant change in the noticeable conditions going downstream as we head down the river toward the Johnson County area. Well, I don't know, but I guess I'm not confident that, that just diluting it out is the best answer for this. I think anytime we start adding a bunch of extra stuff to our water purposefully, it's a slippery slope that we start looking at. So in conclusion, the future of Kansas and its ability to sustain and grow does depend on our ability to maintain water resources. If you're looking for any further information, you can go to any of these websites. The USGS for Kansas Water. You could also look at the Kansas Water Office, the Kansas Department of Health and Environment, or the EPA site for Kansas water in the Midwest.